these distance will be the same. So that means the difference of the distance between the two focus to any point on the hyperbola will be equal. Latest rectum of an hyperbola is the line segment perpendicular to the transverse axis through any foci whose end points lie on the hyperbola. This is the standard equation of the form y square by a square minus x square by b square is equal to 1. In this case, we have a greater than b. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. So here we are at the last session of the chapter Conic section, and in this session we are going to learn about the hyperbola, the fourth type of conic section. So an hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. So you can see here we have two types of parabola. So one is along the x-axis. So this is again called as horizontal formation of hyperbola, and this is a vertical formation of hyperbola. So how do we get this type of curves? So if you consider these two as a focus, so here the focus is always outside the vertex. So if you consider this as focus F1 and this as focus F2, consider any point in the hyperbola. So let me consider this as P1. So the distance of P1 F1 and the distance from P1 to F2. So that is P1 F2 is maximum. So I am subtracting them. So P1 F2 minus P1 F1. Now take this point. So let me consider this as point 2. So take the distance. So this is P2 F1 and minus P2 F2. So these distance will be the same. So that means the difference of the distance between the two focus to any point on the hyperbola will be equal. So therefore, we'll get a curve, set of points towards this direction as well as set of points towards this direction. But these are only one curve, but they never intersect each other. So depending upon the difference of the point and their distance from the two focus, we'll get a curve like this. So this type of curve is called as hyperbola. So now again based on the x-axis and y-axis, we have two orientations of hyperbola. So here this is along x-axis. So the end points of the hyperbola along the x-axis here are called as the vertex. Again along the y-axis it will be considered as the end point, which is considered as the B. So here we do not call it as a major axis or minor axis. So the line segment joining the focus, the center, is called as the transfer axis. So here this is called as the transverse axis, and again it is considered as the major axis itself, whose distance is given by 2 times a. So next here also you can see the transverse axis is this, but it is along y-axis. So therefore the distance will be a. A plus a will be 2a here also, but the length of the transverse axis will be 2a whether it lies on the y-axis or x-axis, and the length of the minor axis, so the distance here, so the end point where the end enters, so the distance may be considered as b. So the length of the conjugate, we call it as conjugate axis, so that will be represented as 2b. Same here also, here also. Whereas the standard equation of this type, where the transfer axis lie along x-axis, will be given by x square by a square minus y square by b square is equal to 1. If the transverse axis lies along y-axis, then the standard equation takes the form y square by a square minus x square by b square is equal to 1. Now talking about the focus and vertices, it is same as an ellipse. If it lies on the x-axis, then it is plus or minus c, 0 for foci, plus or minus a, vertices. If it lies along the y-axis, the vertices will be 0, plus or minus a, and the focus will be 0, plus or minus c. And when we talk about eccentricity, you can observe in both ellipse, the focus distance from the center is always greater than the distance of a vertex from the center. That means C is greater than A. And we know that eccentricity is a ratio between C and A. So therefore, eccentricity value of an hyperbola is always greater than 1. So thus we can say the two fixed points is called the focus and the center of the two focus is origin. The line segment passing through the focus and the center is called as the transverse axis. The line perpendicular to the transverse axis and passing through the center is called as the conjugate axis. And the end points of the hyperbola on the transverse axis are called as the vertices. So now some important things to remember here. Hyperbola is symmetric with respect to both axes. So when you observe the figure here, so the area underlying with the hyperbola is same as the area below the x-axis. So similarly, here also you can see this portion is exactly the mirror image of this portion. That means they are symmetrical to each other. Next we have the foci are always on the transverse axis. Length of the transverse axis is 2a and conjugate axis is 2b. Next we have a latus rectum. So again a latus rectum of an hyperbola is the line segment perpendicular to the transverse axis through any foci whose end points lie on the hyperbola. And again as in the case of ellipse we have the length of the hyperbola as 2b square by a. So you can see this will be the latus rectum. So here this can be the latus rectum, which is perpendicular to the transverse axis and passing through any one of the foci of an hyperbola. Next is find the coordinates of the foci, the vertices, length of latus rectum, eccentricity of hyperbolas. We have an equation x square by 9 minus y square by 16 is equal to 1. So this is the standard equation of the form 1. So here x square by 9 minus y square by 16 is equal to 1. So here remember in an hyperbola always a is less than b. So therefore a square is equal to 9, which implies a is equal to 3. B square is equal to 16, which implies b is equal to 4. As in case of an ellipse, we have a relation between the transverse axis, the conjugate axis as the distance of the center and the foci. That is given by c square is equal to a square plus b square. So there we had a relation a square is equal to b square plus c square. So the unknown quantity can be interchanged to find the value. So here the relation is c square is equal to a square plus b square. So here c represents the distance of the foci from the center, a represents the length of semi-transverse axis, b represents the length of semi-conjugate axis here. So now here we need c square. So c square is equal to 9 plus 16, which is equal to 25. So therefore c is equal to 5. Now the first thing is we are supposed to find the foci. So now it is clearly of the type 1. So therefore foci lies along the x-axis. So therefore it is plus or minus c comma 0. So therefore it takes the value plus or minus 5 comma 0. Next we have vertices. So vertices is plus or minus a comma 0, which is equal to plus or minus 3 comma 0. Next we have length of latus rectum. So length of latus rectum is here also it is 2b square by a, which is equal to 2 into 16 by 3. So which is 32 divided by 3. The last one we have eccentricity, which is c by a, which is 5 by 3. So clearly you can observe here eccentricity of an hyperbola is always greater than 1. Next we have y square minus 16x square is equal to 16. Let us divide the complete equation by 16. So we get y square by 16 minus x square by 1 is equal to 1. Again here this is y square by a square minus x square by 1 is equal to 1. So now this is the standard equation of the form y square by a square minus x square by b square is equal to 1. In this case we have a greater than b. So now we have a square is equal to 16, which implies a is equal to 4, b square is equal to 1. So b is equal to 1. So we need c square or c, so which can be written as c is equal to root of a square plus b square. So which is 16 plus 1, so we get root 17. So root 17 is the value of c. So now let us decide the foci. So clearly the transverse axis lie along the y-axis. So therefore, foci can be taken as 0, plus or minus c. So therefore, it is 0, plus or minus root 17. Next, we have vertices. So vertices is 0, plus or minus a. So which implies 0, plus or minus 4. Next, we have length of latus rectum. So length of latus rectum is equal to 2b square by a. So 2 into 1 divided by 4, which is equal to 1 by 2. Eccentricity is c by a. So root 17 divided by 4. So the next condition is we have to find the equations of the hyperbola satisfying the given condition. So vertices plus or minus 2, 0, foci plus or minus 3, 0. So now observing the coordinates here, we can see the vertices and foci lies along x-axis. So therefore, the standard equation is of the form x square by a square minus y square by b square is equal to 1. Now from this we have a is equal to 2, c is equal to 3. We need to find b square. So b square can be written as c square minus a square, because we have a relation that c square is equal to a square plus b square. So using this relation we can find b square. So which is 9 minus 4, 5. So therefore the equation becomes x square by a square, 2 square is 4 minus y square by b square. So b square is 5 is equal to 1. So this is the required equation of an hyperbola. So next one we have foci is equal to 0, plus or minus 13. So here the coordinate lies on the y-axis. So therefore here the value of c is 13. And length of conjugate axis is 8. So when I say length of conjugate axis, it is 2b is equal to 8. So therefore value of b is equal to 4. So now the standard equation will be of the form y square by a square minus x square by b square is equal to 1. Because looking at the foci coordinate, the transverse axis is along y-axis. So now here we need to find out the value of a square. Now since we know the relation c square is equal to a square plus b square, we need to find out the value of a square, which can be written as c square minus b square. So 13 square will be equal to 169 minus 4 square is 16. So therefore this is equal to 153. So this implies y square by 153 minus x square divided by 16 is equal to 1. So this is the required equation. So the next one we have foci is equal to plus or minus 3 root 5, 0 and the length of latus rectum is equal to 8. Now we have here foci as 3 root 5, 0, which means the foci lies on x-axis. So therefore c is equal to 3 root 5 here. Also they have given latus rectum 2b square by a is equal to 8. So when we cancel this, we get b square is equal to 4a. We know the relation c square is equal to a square plus b square. So which becomes a square plus 4a. And c square is 3 root 5 whole square, which becomes 45 is equal to a square plus 4a. Or else we get a square plus 4a minus 45 is equal to 0. We can write this as a square plus 9a minus 5a minus 45 is equal to 0. Or we get a plus 9, a minus 5 is equal to 0. So a is equal to minus 9 or a is equal to 5. So we cannot take the value of a as minus 9. We'll take it a as positive. So therefore, now substituting the value of a is equal to 5 here in this equation, b square is equal to 4a. So this gets 4 into 5, which is equal to 20. Now since the foci lies along the x-axis, the standard equation will be of the form x square by a square minus y square by b square is equal to 1. So therefore this implies x square by a square 25 minus y square by b square 20 is equal to 1. So this is the required equation of an hyperbola. So the next question is, we have vertices plus or minus 7, 0. So which means they have given plus or minus a, 0. Observing the coordinate, we can recognize the standard equation of the form x square by a square minus y square by b square is equal to 1. Also, they have given eccentricity is equal to 4 by 3, which means c by a is equal to 4 by 3. So the value of c is equal to 4a by 3. A value is 7, so 28 by 3. Now we have a value, but we need b square. So to calculate b square, it can be taken as c square minus a square. So which is equal to 28 by 3 whole square, which becomes 784 divided by 9 minus 49. So solving this, we'll get b square is equal to 343 divided by 9. Now substituting here in this equation, we have x square by 49 minus y square divided by 343 divided by 9 is equal to 1, or we can write this as x square by 49 minus 9y square divided by 343 is equal to 1. So this is the required standard equation of an ellipse. So this is all about all 4 types of conic sections. So we have learned the properties of circle, ellipse, parabola and hyperbola. So I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.